you how many siblings that you have. And when I ask you, just tell me. I mean, if you got no brothers and sisters, it'd be 0. If you have 1, 2, 3, 4, whatever here. And what I'm doing when I ask you that is I am collecting
Data. Recording data.
Come back here.
You're recording data.
I am recording data.
Your data.
So maybe I'll just go to the bottom. I'll go down here at the bottom. A little bit bigger than these. Why not?
Yeah, this is a little too big.
Well, maybe a little smaller. Maybe a little smaller. Maybe a little smaller. That one, right there. So as I go around, just tell me how many brothers, sisters. Madison, you have 2. Yeah. 4. Joseph.
1. How many
Brothers or sisters. 3. Doesn't matter what there. 2. Caleb. Shannon.
3.
3.
2.
2. Brian.
1.
1. Ella. Chase.
2.
2. Sophia.
1.
1.
2.
2.
1.
I have just 1. That's too bad. 9 more brothers. Emily. 1. Matt.
1.
1. 3.
1.
1 for Lauren. Sarah. 5. 2. John. 3. 3. Lee. 2.
4.
4. See if I got some more room here. Zach. What's that? Just 1?
5.
5. Okay. Now, did I get everybody?
Yeah.
I did. What we have here, children, is what we call raw data. As you look at all those numbers, you know, they are, did I miss something?
No, are we supposed to be writing those numbers?
Yeah, you should have wrote them down, write them down. Not that hard, there's only 20, what of them, 24 maybe, or whatever it is. 22, you can jot them down. Okay? That's raw data, and it's not organized, and really, you can look at it and maybe you can make some, I don't know, you can look at it and go, oh, I see a couple 3s, a couple 1s, they're all kind of scattered about there. Okay? Data is only as good as your organization of it, and that's what we're going to do here. We're going to take your raw data, and we are going to make, don't worry, it's not going to go away, it'll just get a little smaller. Or it's going to get really small.
Yes.
We are going to put it in what we call a frequency table. And while you're writing that down, I'll give you this sheet so you can have it there. Write down those numbers. Because we are going to take this raw data and we are going to organize it so at least we can make some heads or tails out of it.
Are we supposed to get some jokes?
So we can figure out some sort of because raw data in itself isn't very useful for it. You know, maybe we were trying to see if we could sell most candy bars or something. So yeah, you can put it in there in a minute, but after we finish with it here. So what we're going to do here is we're going to organize our data using a frequency table. Okay? And here we have tally and frequency. We'll talk a little bit more about those in a second. The first thing we're going to jot down is what we're talking about in our little heading here is the number of siblings, or brothers and sisters if you want to do that. And what we got for responses, actually we didn't get anybody, nobody here is an only child, that's kind of unusual. Okay, so we have people that had just 1 sibling, 2 siblings, 3 siblings, 4 siblings, or 5 siblings were our only choices there, right? And a quick way to count, rather than trying to look at it all and do it all at once, is to make tally marks. And you're familiar with tally marks because we've done that. So as we go through this data, we're going to put tally marks for whatever it is. So we start here, we have a 2, we have a 4, Stay with me here. We have a 1. We have a 3. We have another 2. And another 3. And another 3. And a 1. And a 2. And a 1. And a 2. And a 1. And a 2. Oh look, you get to make a little mark there. And a 1. Another mark there. And a 2. And a 5. Oh, finally we get to the 5. A couple more 1s. A 3. A 1. A 5. I thought we had more of them. Was there more than just 1? A 3 and a 4. Did I miss any? Wait, we got them all there. And then, just to make the numbers easier, rather than having to count up all the tally marks, our frequency means how often. How often did we get a 1? Well, we count up the tally marks 8 times. How often did we get a 2? 6 times. How often did we get 3 siblings? 5 times. How often did we get people with 4? Boom. How often did we get people with 5? Twice. And then you can look at this and see now it's kind of organized. You can kind of make some heads or tails. Like, you know, you can right off the bat say, well, the majority, not majority, but a good number of people, a lot of people have just 1 brother or sister. 8 of you, right? Just have 1 brother or sister. 6 of you have 2 brothers and sisters. Oh, a couple of you actually have 5. Christmas must be an interesting. A lot of presents there. But you know your presents, your birthdays, brothers, whatever you have. So that is a way, you know, you take, tally marks help you organize it, frequency gives you that, and this is a way you organize data so that you can take a quicker look at it rather than looking at all these numbers and try to figure something out. You can look at the frequency and how often it happens, and you can see that very much. Another way to do it, write this on your other piece of paper. Another way to organize data is what we call a line plot. I don't think we've done line plots, have we? And with a line plot, it's another way to organize data. Write these down. And you can write these down as I do this here. Supposedly, some guy stood at a water park, beautiful day for a water park, and wrote down the ages of the first 20 people who went down the slide. Here were their ages. First one was 11, then 9, 8, 11, and 12, 8, 11, and 12, 15, 13, 12, 15, 13, 12, 17, 12, 17, 12, another 12-year-old went down. Oh, here comes an old person. 22, 13, 11, 21, 9. I guess you see old people at the water park, right? 16, 12, 13, 9. 16, 12, 13, 9. Those are all people, the ages of the first 20 people that went down a water slide. Ages of sliders. Now, to make a line plot of this, and this is another way you can organize data, you could make a frequency table with this, but there's a lot of different numbers. You'd have to have a lot of columns, and it may not look as nice as this. What you do is draw a number line. And this number line has the whole range of numbers. What's the youngest person we had there? We go all the way from an 8 to a 22-year-old. So you're going to need to do that. You know, 5, 6, 7, 8, 9, I don't know why I started it. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. And you probably want to put some numbers down here, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Because you don't want to have to count every time. So now I've got my number line that has all of these numbers in it. And what you do is, for every age, you put an X above the number where it shows up on the line. So here's an 11-year-old, so here at 11, I put an X. Here's a 9-year-old, so at 9, I put an X. Here's an 8-year-old, so I put an X there. Another 11-year-old, so I put a second X above it. So for every 11, it's going to climb up there. Here's a 12-year-old, a 15-year-old, a 13-year-old, a second 12-year-old, a 17-year-old, 2 more 12s, my old 22-year-old, a 13-year-old, an 11-year-old, oops, that wasn't what 11 was. Did I put the 13 in the wrong place? What 13 should I have? I should have 2 13s. And I think I put that as an 11. There's a 21, and a 9, and a 16, and a 12, and a 13, and a 9. I think I got, do I have one up? 4, 7, 10, 15, 20. And then once you do that, children's, your data is organized a little bit there. You know, and you can see if I asked you, generally speaking, how old are people that go down the slides, we look for groupings or clumps or lumps or, you know, places where they're kind of lumped together. And you can see this is kind of the age that most people who go down that slide are. How old are they usually?
10 to
9 to 13, and the majority of them are actually 11 to 13-year-olds that go down that slide. More so than anything else. You don't get a lot of people younger than 10, you don't get a lot of people older than 15. You know, what type of slide would you assume that is? Oh, how big? Like death-defying slide or?
Yes. The one I made.
What's that?
It's not. No, it's
This is what we call a cluster, because a cluster, you ever heard of those peanut clusters? They're all grouped together in a little, like the little chocolate peanuts.
chocolate.
And these, when you have numbers that are outside, you know, look at how far away from, when they're ways away from what the normal is, these guys are called outliers. You know, they're like that 95-year-old guy that goes down the slide. You know, he kind of messes everything up if you're looking at data, because he's so far out of, if you're looking at ages, you don't even want to talk about him because he would make everything kind of all messed up as far as that goes. Okay, and then we've got a couple other, we've got some other words we need to talk about here in case they come up here, and they are these. Let me see if I can. You need to make this a little smaller. I don't know if I'll be able to do it or not. Oh,
Whoa.
yes. Listen to Alex, you know, he's been here. Write down these words so you know what they are. We have the range. Anybody know what the range is? If I ask you for the range of those numbers, it's the difference between the high and the low. In other words, these numbers went from 8 all the way to 22. You take those numbers and take 22 minus 8, and your range is 14. There are 14 numbers between 8 and 22. That's what the thing that the numbers range between. Okay, they're the things that the numbers range between. Then we have what's called the mode. And the way that I remember mode is I look at those first two, actually, sorry, I wrote what I was thinking. We have the mode, and the way I remember the mode is take those first two numbers. It's the numbers that happen the most. And if you look at this thing here, which one happens the most? It's right here. Yep. Number 12. The mode of this is the number 12 because it occurs the most. It occurs the most. Then we have what's called the median. Anybody know what a median is? When you're driving, there's a median. What is it? Anybody know what a median is? Median is that little curve they put in the middle of the road so you can't go cross over from one side to the other, like on an expressway. Piece of grass. Usually it's grass there. Sometimes it's curved in the city. It is the number that is in the middle. Now, in this case here, this gets a little tough. How many numbers did we have? Remember? Took the numbers of how many people that went down the slide? 20. So if you have 20 things, all lined up, which one is in the middle of 20? What's in the middle of the 20th number? If you have 20 numbers, what number would be in the middle, Joseph?
10.
Number 10. So we'd have to count over from small to big and get to the 10th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The median, the middle number in this is going to be 12 because it is 10. If you lined everybody up from smallest to biggest, the exact middle of that line would be that person whose age is 12. And then we have one last thing, which is the mean, which I don't know if we have to do. Does it tell us mean? It doesn't. We don't have to do mean, because mean just doesn't happen. Wait, have we done average? We have done average, haven't we? Oh. Well, let's write that down. Because mean is just the average, but we're not going to average all these out. You could probably give me a good guess as to what the average is. The average is probably somewhere here in between 11 and 12, something like that. But that's what mean means is average. Now, take a look at page 321, please. Well, yeah, you can take a look at this. We got a couple more things to talk about. One of them is a pictograph. Why don't I write it right here? Pictograph. What is a pictograph, you ask? Jacob Homerding? What is a pictograph? It is a graph that uses pictures. In other words, if I was a pizza place and I was trying to make a graph of how many pizzas I sold on Monday, Tuesday, Wednesday, Thursday, and let's just do Friday. If I was making a graph of those, sometimes it might be fun and clever. I'm going to make this bigger because it is not wide enough for me to draw it. Oh, let's make it not like that. Okay. Let's say I was a pizza place and I sold, 15 pizzas on Monday. Well, you're going to draw pizzas to stand for something, but you have to figure out what would be the best. Let's say I did this. I drew 3 pizzas. Let's put some pepperoni in there. Okay. if I sold 15 pizzas on Monday, how much would each of these pizzas have to stand for? Lauren? 5. So somewhere off to the side here, there's a key that says every pizza equals 5. So then let's say on Tuesday, I guess I only sold 10 pizzas. That means I would only have 2 pizzas drawn. Wednesday, let's say I sold 20 pizzas. That means I would have a picture of 4 pizzas. I didn't pick the best numbers, by the way, for my pizzas. Now here comes a question. What if on Thursday I only sold 13 pizzas? How would I ever go about, since each pizza stands for 5, again, I didn't pick the best number, so this is Zach Roth.
You would draw, 2 pizzas
2 whole pizzas, because that would give me 10, right?
and then draw a third.
Yeah, unfortunately, I should have picked even numbers, but it'd have to be 3/5 of another pizza, so you'd kind of have half of a pizza there. It kind of look like that. I should have picked a different number. I should have went with 10 and have everyone stand for 2 or something like that. And then on Friday, let's say we got real crazy and we sold 25. 1, 2, 3, 4, 5. But a pictograph just kind of use pictures to stand for your things. Just makes it probably just a little bit more exciting. So the first thing you have to do is look and see what your pictures stand for. And then, wait, did I tell you? Oh, look at page, are we on page 322?
Yeah.
Look at page 322. At the top of the page there, you're looking at a pictograph. And the first thing you do when you look at any graph, ladies and gentlemen, boys and girls, is look at what the graph stands for and what the things all mean. What does that graph stand for? What's the title of that graph? It is how many dinners served. And each plate stands for, man, how many dinners?
10 dinners.
10 dinners. So on Tuesday, how many dinners were served, Cassie? On Tuesday, Cassie, how many dinners were served? 40, yes, we're all good there. What about on Saturday, how many dinners were served? Brian?
40.
Wait, on Saturday?
Oh. 70.
70, obviously. And then look at the next graph down there. Then we have an example of a bar graph. And the same thing is true, boys and girls. You need to look at what these bar graphs mean. What is this bar graph about? What's the title, man?
Favorite school.
Favorite school lunches. And what are your choices in your favorite school lunches, Jacob? I want to know whose favorite school lunch is a salad.
Me.
Would you really pick that? Over a plump, juicy hamburger?
Yeah.
Okay, I would never I
And then, of course, you got to look at the left side of the graph there. What does each line stand for? Well, the left side says how many students, number of students. So how many people like pizza as their favorite lunch? You might have to do a little calculating here, Grace. 9. How many people like spaghetti? Spaghetti was, Chase?
5.
5. How many people like salad? Unfortunately, that is Connor. 8. What about question 18? It says, what is the total number of students represented by the 4 bars in the graph? So how many total kids did they ask? Wow, can we do that math? Looks like it's 9 plus 6 plus 4 plus 8. 9 plus 6 plus 4 plus 8. Lauren? 27. And then the last graph to look at there, look at graph number, example 3. There's a broken line graph. Why do you suppose, when do you suppose you'd use a line graph as opposed to a bar graph as opposed to a pictograph? What do line graphs show? And when do you usually see line graphs? Sittler?
Like, sometimes you see the line graphs for like how much your taxes are.
Yep. Anytime you want to look at how things are changing, like Madison talked about, how much your taxes went up. If you see a line, you can see it really fast that it went up. Maybe the next year it went down a little bit, but then it went up again. You know, so that's when you use a line graph. What is this line graph about? It is about the altitude of a model airplane during a 70-second flight. So, if you're telling me what that model airplane did, how did it fly? If you're looking at that line, it looks like it went up for the first 20 seconds, and then what happened? What happened after 20 seconds? Nope, it didn't go down after 20 seconds. It stayed the same for the next 10 seconds. It's leveled out. And then what happened in the next 10 seconds after that, Sophia? It went up really fast. And then after 40 seconds, it, Maya, went down. Then from 50 to 60, it didn't go down quite as fast. And then apparently at 70 seconds, it must have crashed. And then the question it asks you, what is the maximum altitude reached by the model airplane? What was the highest it got? Joseph? What's that? No, altitude, you have to move the feet. What's the highest it got?
40.
No, went higher than 40. 80 feet. Question 21 says, how many seconds during the flight did it fly at a constant altitude? Which means stay the same. Constant means stay the same. How long did it stay the same, Caleb?
40.
No, it doesn't say what time, it said how long. How many seconds did it stay the same? No. Each one of those little things is 10 seconds. Gianna? 10 seconds it stayed the same. Then it went up, then it went down, and it crashed. Oh, look, we've got more. Turn the page. Oh, wait, it says using your one. You apparently didn't make it. It says make a bar graph. It says make a pictograph. I don't want to do that. Let's look and see if there's something else we should look at. No, no. Maybe we should just punt and call it a day.
Yes. No, we should not.
Nope.